section 12.1, sequences. I want you to think of a sequence as a function, okay, that maps the term number to the term. That's all. So the domain or the input to the function is the term number. Term number. So like term number 1, term number 2, term number 3, and it actually helps to list these term numbers by the term ... and then term number n. And what we're looking for is a way to go from the term number to the actual number in the sequence, and that's the range, or the output is the actual term in the sequence. So term number and the actual term. So we could represent it by a sub 1 for the first term, a sub 2 for the second term, a sub 3, ... and then a sub n is the actual nth term. Okay? So sequence is just a set of numbers separated by commas. That's it. You can have an infinite sequence where the numbers go on and on forever. You can have a finite one where there's just like 3 terms. So there's 2 different directions we can go in. The first direction is we write out the terms given the equation. So write the first 4 terms. Write first 4 terms. So we're actually given the equation, and we just expand on it. So the first example, let's say I use this notation, function notation. F of n equals -2 raised to the n minus 1. It's a somewhat complicated formula, but you didn't have to come up with it. It was given to you. And we want to write out the first 4 terms. So you let n equal 1, and you plug it in, 2, 3, all the way up to 4. So let's see, let n equal 1 for the first term. So we actually just substitute 1 into this. So that gives me -2 raised to the 1 minus 1. If I literally plug in the term number into the equation, and I need to evaluate that, that's -2 raised to the 0 power, and anything to the 0 power is 1, not 0, 1. Yeah, anything to the 0 power is 1 by definition. So then we would just, repeat this pattern. If n is 2, you get -2 to the 2 minus 1 power, which is -2 to the 1 power, which is -2 to the 1 power is simply -2. And then we do the same for n is 3 and n is 4. So this is -2 to the second power. This is going to be -2 to the third power. If we just follow the same pattern, so this would be 4, and this would be -8. So our sequence is 1, -2, 4, -8. And we'll talk about in a second how to go from the sequence back to the formula. So basically that's the goal in this part, is how do you take an equation and write out the sequence, or take the sequence and write out what the equation is? Which direction is harder? Actually finding the formula is far harder than expanding it. Yeah, for sure. Okay, so are there any questions on how to write out the terms given the formula? Okay, let's focus on the part that's harder. So how do we write the rule for the nth term? So this is like part 2 is we want to be able to go the other way. So write the rule for the nth term. So let's take example number 2. Okay, so let's try to start out simple here. So let's say I have 1, 4, 7, 10. Okay, so tell me what kind of sequence is it? Yeah, it's arithmetic, because what constant are we adding every time? Okay, so we see that we're adding 3, and we know it's arithmetic, and actually the first few examples are all going to be arithmetic. we're going to do 3 examples of all arithmetic. If you notice that it's arithmetic, this is how you would always do it, okay? And this is what you were doing in your worksheet a second ago. So you're always adding 3, but that doesn't tell us how to write the formula, right? So what you do is you just back up one term. You go to the 0th term. So this is term 1, 2, 3, 4, right? But if I went backwards one step, what would that term be? Good. It would be -2 is the 0th term if I just backed up one step. So when you write your rule, the easiest way to do it is to use -2 as your starting place, and then you just add 3n. And that's the formula. You take the 0th term, and then you add whatever you're adding, like 3, you add multiples of 3, so it goes like this. The final answer is t sub n equals -2 plus 3n. Done. And you definitely want to test and make sure it works. So you go, okay, let's make sure it works. If I plug in 1 for the first term, -2 plus 3 times 1, is that 1? Does it work if now I want to go back the other way to check my answer, right? It's a quick quiz and I have to get it right, so I got to check. Does this formula work? If I expand it out, would I get this sequence back? If I plug in 1, what do you get? What do you get when you plug in 1? 1, yeah. What do you get when you plug in 2? 4. What do you get when you plug in 3? 7. What do you get when you plug in 4? Okay, it works. Okay, so we're good. Let's do another, at least one more of that exact type where it's arithmetic. So example 3, let's try, we have a sequence like, let's try something a bit harder here. Let's try at least one that is a little different. Let's try this, yeah. 7, 5, 3, 1, -1. Okay. This is the last one for arithmetic. So what's happening here? Yeah, we are adding -2. Always think about it in terms of what you're adding, because it's arithmetic, so we're adding a constant. We're adding -2, right? So if we back up, how do we get, what's the 0th term then? 9. Good. It'd have to be 9, so that when we go to the next term, when we add -2, we get 7, and then when we add -2, we get 5, and then we add -2, we get 3. It has to be consistent. So the final answer, I'll write it. I'll use the other notation. A sub n equals, you'd start with a 9, and then you would add -2 n times. That's the formula. So it's always the 0th term, and then whatever you're adding goes in front of n, and that's the formula. So we got to try it. If I plug in a 1, what do I get? If I plug in a 2, what do I get? If I plug in a 3, what do I get? If I plug in a 4, okay, it's good. All right, now, what do we do if it's not arithmetic? Okay, so first of all, I will say, if it's geometric, we'll do a whole different lesson on how to do that. So nothing you're going to see is going to be geometric right now. So we're going to save that for later. But what you will see are other kinds of special patterns. So let's try to deal with those. So if it's not arithmetic or geometric, it's some sort of special pattern. And it's going to be based on perfect squares or multiples of something. So it's going to be something like, it'll be around like your perfect squares, like our 1, 4, 9, 16. It'll be related to that. Like it'll be 1 more than or 1 less than. It'll be related to a perfect square. It might be n cubed. It might be related to n cubed. It might be related to, say, 2 to the n. So something like, if I wrote those out, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16. It might be related to that. So it'll be some combination of a perfect square, a perfect cube, and the only thing I can tell you is to compare it to the sequence number and keep trying things till you get it. And I can also tell you that the more you do it, the more you'll see it's related to one of these patterns. So let's try a couple here, and then we'll be done with this part. So let's try example 4. Let's give you a sequence like Let's do 2, 5, 2, comma 5, comma 10, comma 17. Okay. So the first thing you want to do is see if it's arithmetic or geometric, and it's neither, because if you're not adding the same thing each time, it's not arithmetic, and if you divided, you're not multiplying by the same thing every time either. You're just not. So let's compare it to these numbers. The sequence number 1, sequence number 2, 3, 4. What do I do to these numbers to get the term? What do I do to 1 to get 2, 2 to get 5, 3 to get 10, 4 to get 17? That's it. You square these numbers and you add 1. So they're related to the perfect squares. You square the sequence number and you add 1 each time. And I can write it out each time. I'm squaring the sequence number and adding 1. So you go right to your answer. There's not a lot of work to show in these, which you might like. So T sub n is n squared plus 1. And that is the answer. It's a perfect square plus 1. And so for all these, you're going to have to try. Let's try one more. 1/5, 1/10, 1/15, 1/20. It's not arithmetic or geometric, but you do see a pattern. It's something natural, I think, for us to see patterns. So what do you notice? Or what do you think the answer is? T sub n equals? Well, let's relate it. So this is relate that somehow to 1, to 2, to 3, to 4. How are those related? Yeah? What do I do to 4 to get 20? What do I do to get 3 to get 15? What do I do to 2? Sorry? You see it? Yeah, good. You multiply by 5, exactly. So the 1 on top is the same, and on the bottom you multiply the term number by 5. That's the answer. You always have 1s on the top. That stays a 1. And then you can always check your answer and try something else if you don't get it the first time, so you will do great.